Okay, here we go. Today I'm going to show you how to factor polynomials that have 4 terms, which is something that we haven't dealt with before. We've only dealt with 3-term polynomials, or those 2-term special polynomials that were the result of special products. So we've never done a 4-term polynomial. And this is useful to know for 2 reasons. One of the reasons is that sometimes you'll have polynomials with 4 terms, but another reason is that we're going to eventually start to factor more complicated 3-term polynomials or trinomials, and one of the tricks that we're going to use to factor those harder polynomials is by taking the 3 terms and splitting it into 4 and doing what is called factoring by grouping. So factoring by grouping is where we're headed with this eventually, but for now we're just going to do polynomials that have 3 terms. So for example, you might have an x cubed term, an x squared term. Let's just do a plain old x term and a constant. So this is an example of a polynomial that has 4 terms. And so the first thing that you do, step number 1, is going to be to actually divide the polynomial into 2 sections. Okay, we're going to have the section on the left and the section on the right. That is made up, section on the left is made up of these 2 terms, and the section on the right is going to be made up of these 2 terms. And what we're going to do, step number 2, is we're going to see if we can factor out a greatest common factor from just that one side. So for example, if we look just at the blue side, the x cubed plus 7x squared, what is the greatest common factor of x cubed plus 7x squared? And the answer is x squared. So we would put x squared outside the parentheses. We are only looking at the blue part here, only the part on the left. So if I divide both of those terms by x squared, what am I left with? Well, I'm left with x plus 7. Okay, great. Halfway there. Now I'm going to do the same thing with the right side, the side that I did in green. So I have 2x plus 14, and the greatest common factor of 2x plus 14 is 2. So I'm going to do plus 2, plus because it's positive 2, which would leave me with x plus 7. Now what you'll notice is something kind of interesting has happened when I factored out those greatest common factors. What's happened is the part that's in parentheses here is the same for both of these terms. It's the same for both of them. They have what is called a common binomial. Think of it like this. Imagine that instead this was x squared times something plus 2 times something, and the something was the same. I don't even care what it is. If I asked you just to factor the greatest common factor out here, it's a little silly to think about, but the greatest common factor is that yellow square. So what I would do is I would put yellow square on the outside, and what I'd be left with on the inside would be x squared plus 2. You can verify that this is correct by doing the distributive property. Okay? If I were to do yellow square times x squared, I'd get x squared yellow square. And if I were to then distribute the yellow square to the 2, oops, it's a pretty fancy little highlight I did there, I would get 2 times the yellow square. So I end up with the exact same thing by factoring out the yellow square. So that's a really convoluted, complicated way of saying that what we're going to factor out is the binomial that they have in common. Both of these terms here have an x plus 7 in common, so we're going to factor out an x plus 7. Okay, so I factored out this x plus 7, and I factored out this x plus 7. After I factored that out, what was I left with? Well, I was left with x squared and a plus 2. That's going to be my other set of parentheses, x squared plus 2. Great. So it's all well and good, take my word for it that this is how you do it, but you can check your answer just like we checked our answer with any factoring problem, which is by using the distributive property. So let's go ahead and do the distributive property. I'll do x times x squared, that's x cubed, and then I'll do x times 2x, which is 2x, and then I'll do 7 times x squared, which is 7x squared, and then I'll do 7 times 2, which is 14. That looks pretty close to my original problem. Here's my original problem up here. Looks pretty close to that original problem, except it's in a different order. So if I were to just take the oops, if I were to just take the 2x and the 7x squared and flip them, now it looks exactly like my original problem. So that's factoring a polynomial that has 4 terms. You take the 4 terms, you split it in half, divide it into the left side and the right side, then you find the greatest common factor for the left, and you find the greatest common factor for the right, and if you've done it correctly, that will leave you with a common binomial. That common binomial is one of the sets of parentheses in your answer, and the thing that's left is the other set of parentheses in your answer. Now, if you're thinking to yourself, what happens if I factor out the greatest common factor and the parentheses aren't the same? Well, there are one of 2 possibilities. Possibility number 1 is it cannot be factored using this method. And possibility number 2 is it can be factored using this method, but you chose the incorrect greatest common factor. Maybe you chose a common factor, but not the greatest common factor. For right now, it's always going to be the second one. I'm sorry to say, we're not quite ready for ones where you can't factor using this method, so if it doesn't come out to have a common binomial right now, it means you picked the wrong common factor. We'll talk a little later about what happens when you do pick the common factor and it still doesn't work out. But for today, we're going to try to keep it as simple as we can. Let me give you another example. They don't have to have x cubed and x squared every single time. I'll give you some in a little bit that aren't, but for now we're going to do cubed and squared for everything. Okay, so here we go. How am I going to factor this polynomial? Well, step number 1 is I'm going to take this polynomial and I'm going to divide it exactly in half with 2 terms on the left and 2 terms on the right. So my left side is going to be the x cubed plus 4x squared, and my right side is going to be the 8x plus 32. Okay, so look at the left side, the blue side. What's the greatest common factor? X cubed plus 4x squared. What is the biggest term both of those can be divided by? X squared. So x squared on the outside of the parentheses. And if I divide both of those terms by x squared, what am I left with? X plus 4. Now let's try the same thing with the right side, the side that I boxed in green, 8x plus 32. The greatest common factor of 8x plus 32 is 8, positive 8. If I take 8x and 32 and divide them both by 8, what am I left with? X plus 4. I know that I've done the problem correctly up to this point because they have a common binomial. They both have x plus 4. Since they both have x plus 4 as a common binomial, I know that one of the sets of parentheses in my answer is going to be x plus 4. The common binomial is one of my sets of parentheses. I'm factoring out the common binomial. The other set of parentheses is what's left after I factor out that common binomial. Well, I've got an x squared, and I've got a plus 8. So my other set of parentheses is x squared plus 8. I can check my answer, make sure that's right by doing the distributive property. I'm just going to rewrite it here so I can mark all over it. Take the answer and let's do distributive property. X times x squared is x cubed. X times 8 is 8x. 4 times x squared is 4x squared, and 4 times 8 is 32. It doesn't look exactly like my original problem, which is here, but it's only because the 4x and the 8x are in a different order, so if I switch the 4x and the 8x, I end up with x cubed plus 4x squared plus 8x plus 32, which tells me, in fact, that factoring that I did right here, that was the correct answer, because whenever I do the distributive property, I get the original problem back. Okay, let's try one that does not have cubed and squared. Let's see what one of those would look like. And let's get away from x. Let's try everybody's favorite letter, P. And this problem's a little goofy for 2 reasons. Okay. So, right away it's goofy because it's not cubed and squared and to the first power, and a constant, we've got to the fifth power, to the third power, etc. Not a big deal. We're still going to follow our same procedure, which is that we're going to divide it in half. Make sure that minus sign stays on the right half. Okay, so here we go. My first two sets of terms are p to the fifth and 6p cubed. The greatest common factor of p to the fifth and p cubed is p cubed. So if I take each of those terms and divide by p cubed, what do I get? Well, I get p squared minus 6. Good. So now let's do the left side, which is minus 2p squared plus 12. Now, the other thing that's a little tricky about this one is that this second pair of terms starts with a negative sign. If you're doing factoring and your first term in a pair is negative, you have to factor out the negative. So I have negative 2p squared plus 12. If I just factor out a 2, I'm going to run into some problems. Let me show you. Don't write this down. Let me show you what it looks like if I just factor out the positive 2. Negative 2p squared divided by positive 2 is negative p squared, and 12 divided by positive 2 is 6. And you will notice that I have a problem here. This set of parentheses and this set of parentheses aren't the same. And that happens when you forget to factor out the negative. So if I back up here, and instead of factoring out a positive 2, I factor out a negative 2 like that. Now look what happens. Negative 2p squared divided by negative 2 is p squared. And 12 divided by negative 2 is negative 6. And now my two sets of parentheses are the same. So now I know that I factored it correctly. So if your problem starts with a negative, you have got to factor out the negative. So I think the answer is p cubed minus 2 and p squared minus 6. And I can verify that by doing the distributive property, or you can take my word for it. I nailed it. Okay, so let's try one that's got two variables in it. That sounds like a good time. So let's start with a cubed, then we'll do a squared b, a, b, and then b squared. Lord have mercy, there's two variables. What are we gonna do? We're gonna do the same thing we did for every other problem. Don't be afraid just because it has two variables. All that means is that your greatest common factor might have two variables, which is fine. We've done that before. Not a big deal. Calm down, everybody. It's gonna be okay. So my left side is that. So a cubed plus a squared b. The greatest common factor there is a squared. So I'm gonna do a squared, and then in parentheses, I'll have a plus b. That's not a big deal, right? Simple. What could be easier? I know, lots of things could be easier, but it's not that bad. Next I have ab plus b squared. Greatest common factor there is b, leaving me with a plus b. Do I have a common binomial? Yes, I do. It's a plus b. So that tells me that one of my parentheses is going to be a plus b. What will the other set of parentheses be? It'll be what's left over, a squared plus b. And there's my answer. Nailed it. Probably. Pretty sure I nailed it. Okay, there's one more example that I want to give you, and that's sometimes there is a benefit when you are factoring these to changing the order before you split the problem. You'll notice whenever we did the distributive property on the first couple of these that the order wasn't the same and we had to flip the terms. Sometimes it makes sense to flip the terms before you even split them and start factoring. Let me give you an example. Okay, so there's an example like that. And I could factor it like this. It's not a problem for me to do that, but it might help me a little bit to switch these two terms in the middle. Can you see why it might help to switch those two terms? See why that might be good? The first term has m. Oops. First term has m. and the third term has m, right? You may be thinking, well, yeah, this one had m also. What's the big deal? Well, look at the n's. This last term has an n, and this term also has an n. So it might be easier for me to put the terms with m at the front and the terms with n at the back, so that when I do the greatest common factor, I can factor out an m or factor out an n. So let's see what that would look like. Let's start off by doing a new order that we're going to try. Okay, so now let's split the problem. So there's my first set, 12m squared plus 3m, greatest common factor is 3m, leaving me 4m plus 3m divided by 3m is 1. Don't say it's nothing and don't write it and not write it. It's 1. Now let's look at the next half, 28m n plus 7n. Greatest common factor there is 7n. 28mn divided by 7n is 4m plus 1. Do I have a common binomial? It's 4m plus 1 and 4m plus 1. So there's my common binomial, which means my parentheses would be 4m plus 1, and what's left over, 3m plus 7n, which is the correct answer. Now, what would have happened if I had not rearranged the order? Would it have been possible for me to solve the problem in that original order? Like so. Well, let's try it. We'd split it in half. Greatest common factor here is going to be 4m. All right. Leaving me with 3m plus 7n. And the greatest common factor over here is just 1. So it'd be a plus 1, because there isn't really a greatest common factor, so we just use 1. And that would leave me with 3m plus 7n. Do I have a common binomial? Sure do. 3m plus 7n and 3m plus 7n. So part of my answer is going to be 3m plus 7n. And what's left over? 4m plus 1. So it's the same answer. I got the same answer both times, here and here. These are the same. But this bottom one was a little weirder because of this one greatest common factor. So you can get the same answer. It's just a little more difficult to do it that way, but it's fine either way. So that's how you factor something, a polynomial that has 4 terms, and that's going to lead us into what we're going to be working on in the next week, which is learning how to factor by grouping, which is how we're going to do some of those more difficult factoring polynomial problems that we haven't got to yet. Hope that makes sense. Thank you.